Okay, we are going to find the equilibrium index of an array, which basically is an index such that the sum of elements at the lower indices is equal to the sum of the elements at the higher indices. So for example, if we have -7, 1, 5, 2, -4, -3, and 6, then we know that the index at 3 is going to be our equilibrium because -7 plus 1 plus 5 is -1, and -4 plus -3 plus 6 is also -1. So we have our output as 3. All right, so to do this, we're going to create kind of a pivot that we can keep the sum of the left elements and then the sum of the right elements to the pivot. We can keep track of those, and we can add and subtract as we move across the array. So we will have a pivot. We will have a left sum and a right sum. Okay, and we'll start the pivot at 1, at element 1, or index 1. The left sum would start at -7, the first element in the array, and then the right sum we will loop through and add them up. So 5 plus 2 is 7, minus 4 is 3, minus 3 is 0, plus 6 is 6. So what we're going to do is we're going to look at the left sum and the right sum. Are they equal? No, they're not. Okay, then I know I need to add my pivot, the element in my pivot, to the left sum. So -7 plus 1 is -6. Then I increase my pivot to the next element, and I need to subtract that from the right sum. So 6 minus 5 is 1. Okay, so then I look at it. Is -6 equal to 1? No, it's not. Okay, I need to add my pivot to my left sum, and I need to subtract it from, I need to then increase it to here, and that's where I subtract it from my right sum, and 1 minus 2 is -1. And I also had increased my pivot to 3. All right, and so then I go through and I say, okay, is left sum equal to right sum? Oh, it is. Okay, I have found my equilibrium index, and it's at my pivot point of 3. So let's go ahead and write this up in some code. I'm gonna, well, I think we can do this like this. Okay, so just declare our function. We're gonna be returning an int, and we'll just call this find equilibrium, and it's going to take an array of ints. Okay, so first we're going to do some checks, because in order to calculate this, we need to make sure our array is the right size and everything. So if it's null, we obviously can't find an equilibrium. So we're going to go ahead and put in a statement: if array.length equals 0, then we're going to throw an exception. And it'll say something like array cannot be 0 or be null. Okay, and then else if our array is equal to 1, we have a couple choices, and this is where it would be really great to clarify with the interviewer. But it either could mean that you're going to return a 0 index because theoretically there's 0 sum on both sides of the 1. You could also return -1, saying there is no equilibrium because there are no elements on either side of 1. We'll go ahead and just return 0. And else if the array is equal to 2, then there can't be an equilibrium because there's only 2 elements and you can't have, there's nothing to divide them. So, oops, didn't mean that. And so we will return -1. Otherwise, we can go ahead and rely on our algorithm to do the rest of the checks for us. So if none of those conditions are met, then we can go into our algorithm, and we need a couple of variables. We need to keep track of left sum, and we can go ahead and initialize that to the first element of the array. We need right sum, and we'll start it at 0, but we're going to go through a for loop and get that initialized. Okay, and then we're going to need to keep track of our pivot. And that starts at 1. Okay, so first we can go through and make a for loop to get the rightmost elements. So we can start that at 2 because we're starting right here at this element here. So I equals 2, I is less than array.length, I plus plus, and we're just going to go in and say right sum plus equals array at I. Okay, and that will get us nice and initialized for, or get the right sum all totaled up. And then we can go in and actually take a look at comparing these things. So for this for loop, we're going to start, we can start I at 1, just to kind of keep it like starting around where the pivot is, since we already have the -7 into the left sum. So we can start at 1, I is going to be less than array.length, I plus plus. Okay, so first we want to remember, and we want to check, is the right sum equal to the left sum? So because if that's the case, we can just return the pivot is equal to left sum, return pivot. Okay. Else, we can do, what do we say? We want to take the left sum, and we want to add the pivot point to it. So array at pivot, you could also use I here, since I is kind of in line with the pivot. And then we can say, now this is important, if the pivot is equal to the end of the array, then we don't want to perform this next checker, we'll go out of bounds. So if pivot, so we're going to say if pivot does not equal array.length -1, then we can perform these next functions, and we can say pivot plus plus, because we know we want to increase the pivot. Then we want to subtract it from the right sum. Okay, and then at the final, we're going to get out of all of that. If we didn't find it at any point, we're going to return -1 and exit our program. So, and actually we could put that return outside of the else if we want to. I think it probably shouldn't matter either way. Okay, so now we can go through and see how this works. Okay. All right, so first we go in and we're going to be passed in this array. If array length dot length equals 0, which it doesn't, if array dot length equals 1, which it doesn't, if the array is 2, it's not, then we go into our else. So left sum is going to start at array at 0, which is -7. Right sum, we're going to start at 0, which will be changing soon, and the pivot starts at 1. So we go into our first for loop where I equals 2 and I is less than array dot length, and our length of our array is 1, 2, 3, 7. Okay, we'll just make a note of that. And so 2 is less than 7, so right sum plus equals array at I, so array at I is 5. So this will become 5. Okay, and then I++, we can actually do this. So I started at 2, I++ is going to be 3. 3 is less than 7. So we go right sum plus equals array at 3, so plus 2. So this becomes 7. Okay, I++, I is 4. 4 is less than 7. So we take right sum and we're going to add the element at 4, which is -4. So this goes to 3. I++, 5 is less than 7. So we go in and array at I is -3. So this becomes 0. I++, 6 is less than 7. So we go in and right sum plus equals array at I, which is 6. So right sum equals 6. Okay, then we go out of, and we'll I++, 7 is not less than 7. So we break out of our for loop, we go down to the next for loop. Now I equals 1, and 1 is less than 7. So we go in. If right sum equals left sum, okay, left sum equals 7, right sum equals 6. They do not equal each other. Else, left sum plus equals array at pivot. So pivot's 1, so we're adding 1 to -7, which becomes -6. If pivot does not equal array dot length, pivot is still 1, so it does not equal 7. Then we want to pivot plus plus, so now pivot becomes 2. And right sum minus equals array at pivot. So if pivot's there, it's 5. So then we say 6 minus 5 is 1. Okay, and then I++, I is now 2. 2 is less than 7. So if right sum equals left sum, okay, right sum is 1, left sum is never 6, so that doesn't work. Else, left sum plus equals array at pivot. Our pivot is 2. So left sum plus 5 is -1. If pivot does not equal array dot length minus 1, so pivot is still 2, which is not equal to 7. So, or actually it would be 6, but 2 is not equal to 6. Then pivot plus plus, so now pivot becomes 3. Then right sum minus equals array at pivot. So that would be at the 2. So 1 minus 2 is -1. I++, 3 is less than 7. If right sum equals left sum, right sum and left sum do equal each other, then we're going to return the pivot, which is 3. So that definitely is giving us the output that we want. And the complexity of this algorithm is worst case O of 2n, because we have to loop through, the first loop is not the entire array, but it's practically the entire array. And then the second loop, worst case, we would be looping through close to the entire array as well, so -1 element. So we got a big O of 2n, which is a linear solution.